Hello students, welcome back to my channel. So we have been learning relational algebra. In the previous two sessions, we have learned about various mathematical operations as well as we have studied the various database operations. In today's session, we will see the symbolic notations of those as well as how do we apply them when we are writing a query related to the relational algebra, right? So this is the symbolic notation. Now all these things we have learned already. So projection, we will write it using the symbol pi. So pi is what we will use if I want to use the projection operation. So projection operation is nothing but it will select the subset of a attribute, isn't it? So if there is a table, if I want to select a certain attribute, then I'm going to use a projection operation. This we have studied already. Selection. Next one is a selection. Now selection is used in order to select the rows, particular rows. If I want to select which satisfies the condition, then I will use selection. So it is represented with this symbol. Okay, so if at all you see this symbol, which means it is a select operation. Then we have this renaming row. We use this symbol row if I want to rename a particular table or rename a particular attribute. Okay, then union, of course, intersection, which we already know. How do we represent union and intersection? Next, I have assignment. Okay, certain assignment. If I want to do assignment, so I will use this arrow mark. It can be in either way. Next, we have Cartesian product, join, left outer join, right outer join, full outer join. There is also semi-join, which doesn't come up in our syllabus, but this is how we represent that. Okay, so all these we have studied in detail, and we also have seen the notation. We have used it in the previous session. So today, let us mainly focus on how am I going to apply these notations if at all I'm writing any kind of a query on a relational algebra. Okay, so the symbolic operators are used with the verbal ones. That is, in the previous session when we were learning, we were directly using the keywords select and join, etc. Select from employee, such things we were using. But we can, instead of select, now I can directly use those symbols. Okay. So for example, find all the employees in department 1. Okay. Suppose I have a table department where I have, this is the table or a relational department. This is department number is the attribute, and 1, 2, like that, there are different numbers. So now I want to find all the employees. So when you see all the employees, which means I have to take all the rows where the condition should satisfy is the department number should meet 1, which means I'll be using the select operation, isn't it? So select from employee, isn't it? Where department number is equals to 1 from the table department. So this is how I will write the query. So this indicates select from the relation department. What is the condition here? Department number should be 1. So this is how I will write symbolically. It's very simple, students. In the previous session, we had used the keywords. Instead of the keywords, we will be using the symbols. Right? Let's see the next one. Conditions can be combined together. So, okay. So I can combine, instead of like a simple query, I can use and or. Okay. What is and? And is nothing but both the conditions should be true. And or is nothing but one of the condition can be true. Okay. So see here, for example, all employees in the department 1 called URS. So I have to select all the department and if suppose there is a department name, okay, somewhere it is, if there is URS there, then I should select that. Once again, it is saying all, okay. So I should have a department 1 as well as URS. So same query, I can put it as select department number is equals to 1 and department name is equals to URS from department. Right? This is how I will write the combined queries. Okay, so I hope this is clear. Now, suppose I wanted to take only the particular column. Okay, so now we have seen only the selection. Now, what if I wanted to take a only the attribute? So in that case, once again, if department I want to select only the name of an employee whose department number is equals to 1. Okay, there is department numbers and I want only the name. In that case, project name. Okay, select department number is equal to 1 from department. So this will become a nested query, as you can see. So what is going to happen? First, I'm going to select the rows which have department number is equal to 1. Okay, for example, in this case, I have 3, 4, 5. Suppose there is one more department employee with the department number 1. Okay, let me draw it. So I have 1, 2, 3, 4, 5, 1. Okay, there is some name A, B, C, D, E, F. Okay, E, F. Now, what is my intention? My query was select the name of employee who is working for department number 1. So which means first I need to select the row first. Okay, so in my case, it is here A is working for department number 1 as well as F is working for department 1. Okay, that's why my inner query is select. And then I'm saying from this, I need only the name. So I need to only take the name. So that is why the outer query is project name. So here my output will be A and F, right? So this is how we will write the queries. Next, have a look at this. Sometimes we will also get queries with the table names written somewhat like this example. Okay, try to make it as simple as possible. Suppose there is a banking database which comprises of the following tables. So I have a customer table, I have a depositor table, I have a borrower table. Customer table has customer name, customer street, and customer city. Depositor also has customer name and account number, and borrower has customer name and loan number. Okay, now what is the meaning of this? So whenever you get a details like this, which is nothing but I have a table. For example, the customer table, it comprises of the attributes, 3 columns. One is customer name, another one is customer street, and customer city. Okay, and all the details are filled here. Similarly, the other 2 tables. So, if at all you get a data like this, which means this is nothing but your table name and these are the attributes. Now, before we get into this one, first let us see a simple query. Suppose if I'm giving you a query saying, give the name of the customer who live in a city, Bangalore. Okay, so list all the names of the customer who live in a city, Bangalore. Which means what you're supposed to do now? We need only the name, which means I will project the name. Okay, from where? From, I will select first the customer whose customer city is equals to Bangalore. And from which table am I taking all this detail? I'm taking all this detail from customer table. Right? So this is how I will write the query. Now let us move on to this query. Now that we have seen a simple one, let us make it a bit complicated. Find the names of all the customers who have taken loan from the bank and also have an account at the bank. Okay. Now, how do you find out that? Now we know that borrower is somebody who has taken the loan, isn't it? Depositor is someone who will deposit the money, which means he is the account holder. So now we are asking here, find the names of all the customers who have taken the loan from the bank and also have an account at the bank. So when we combine these two, when we do the intersection, whatever the name we will get, they will be eligible. They will be the eligible names of the customer who have borrowed as well as who have an account. I hope it is clear. So whenever you get a query, make sure that you understand the query first. So find the names of all the customers who have taken the loan from the bank. So how do I do that? I will project. Okay. So loan is nothing but borrower. I will say project customer name from which table? Borrower table, isn't it? That is answer for the first question. Next. And it is saying have an account at the bank. So first let us simply find out who has the account at the bank, isn't it? So customer name inside the depositor. Now, how do I get the answer? I need to combine them together is nothing but I have to use the AND operations. Okay, that is nothing but I have to intersect them. So that is why if I write project customer name from borrower, okay, intersect project customer name from and depositor, isn't it? Depositor. So whatever the output I will get from this particular query is the answer for this query. So that is how I'm going to combine the two tables here, right? So these are the simple queries we are learning. That is, we will not be going into very complicated things, but but when it comes to the relational query, we will try to go in depth a little bit. Okay, SQL queries. So next is rename operator. How do I use that? Because rename we have not discussed in the previous session. Let us see the rename operator. It returns an existing relation under a new name. So that is what it will does. It will just rename a given relation. Sometimes we can even change the name of the attribute also. So we can change the name of the relation, which is nothing but I can change the name of the table as well as the attribute name also can be changed. So we will use the symbol row. Okay. So see here, row A of B is a relationship B with its name changed to A. So after row, whatever I write, this will become a new name and this is my old name. This will go and I will get a new name. Okay. So see the example here. Query to rename a relation student as male student and the attributes of the student, roll number, S name as S number and name. Okay. So I have a relation. Okay. So let's have a look at this. This is the existing student relation. I want to change it to male student. Okay. I want to change this relation name to male student and attributes I have as roll number and S name. Okay, so initially it was roll number and S name. I want to change it to S number and name. So how do I do that? So I will use the rename operator. So I'm using row here. After that, whatever the new names I want, that I'm going to write. So relation name, which is the new name I want, inside that the new attribute names. Okay. And pi. I'm writing this pi because I'm selecting only those. There can be more than one. Okay. So in this particular student, there can be many other attributes also, but I'm wanting to change only the two of them. Selecting roll number, okay, which I want to change. Same order I'm selecting S number and S name. I want to change it to name. Okay. So inside this, select condition, certain condition, whatever the on which condition I want to change from particular student. Okay. So this is a simple query, whichever a regular query. Along with that, I can add a rename operator along with the new names. It's not necessary that every time you have to give an attribute name, you have to change. No, not necessary. You can directly give the relational name or you can directly give the attribute names also. That is possible. Okay. So row is an operator which is used in order to change the names. Okay. Remember, these are the things we are not be using in SQL. SQL, it is used entirely differently. This we are talking about relational algebra. Okay. So when it comes to the SQL, which is the next chapter, we will learn in detail. These are the basic things you should be knowing. That is why I'm not going in depth. Only the basic queries I'm teaching. Right? So finally, in relational algebra, what is the difference between a relational algebra and SQL? Okay. We haven't yet learned SQL, but still I'll try to briefly tell you what is the difference. SQL is our 14th chapter, which we will be starting very soon. Okay. So relational algebra is closed. What do you mean by any operation which is closed? Any algebra or anything? It is nothing but if at all I apply the operations on a table, the resultant whatever we get is also when it is in a relation, then I will call it as closed. Okay. That's why the result of every expression is a relation. That is why it is closed. But in case of SQL, it is a superset of relational algebra. So relational algebra becomes a subset of SQL. Okay. SQL is vast. Relational algebra has a rigorous foundation. SQL has a convenient formatting feature. So it has its own benefits, okay? Has simple semantics, but it provides aggregate functions. It will give us more complex functions. Which one? SQL, wherein which relational algebra has simple semantics. Is used for reasoning, query optimization, etc. It is an end user language. Okay, remember SQL is an end user language, but where relational algebra is not, it is a language which is used by a user, but we will use it for reasoning and finding out certain optimizing things and all those things. But SQL, it is a language itself which end user uses in order to retrieve the data from the database. Okay. Any relational language as powerful as relational algebra is called as relationally complete. Okay. A relationally complete language can perform all basic meaningful operations on relations. So that is why we will call relational algebra as complete. We can do many meaningful operations on relation. SQL is a superset of relational algebra. It is also relationally complete. Obviously, when we say that relational algebra is complete and it is a subset of SQL, we can also say that even SQL is complete, right? So these are the major difference between relational algebra and SQL. So here we will stop with the relational algebra. So we will have learned a very basic things. There is nothing much of the queries you will be writing here, but when it comes to the SQL, you need to know. So select, project, and such operations, intersection, difference. If you have understood, then SQL is going to be easy, right? So very soon we will start with the next chapter also. Till then, keep learning, students, and thank you for watching.